My name is Sandra Bogemuth. I have been with MicroCAD now for 5 years almost. And today we're going to be talking about the role and the concept of digital twins in the AEC industry. So let me get started by kind of exemplifying what is a digital twin. And basically, when we talk about the digital twin, we are going to be talking about dynamic data models of physical assets connected to physical and digital worlds and transforming design, construction, and operations for smarter, more efficient, and sustainable built environments. Um, this technology came into um, concept since 1960s. I have seen it used by the Department of Defense of the United States. Some while ago, assisted to a breakfast presentation that they did of how they used a digital twin of their facilities to do their facilities management. So that is a little bit going into where it has its space. So I'm going to try through this webinar to touch on to different aspects of digital twinning. So first of all, a little bit of history. The initial concepts of digital twins can be traced back to the 1960s when NASA developed mirroring technology to simulate systems used in space via complex physical replicas on the ground. These simulations proved to be critical during the infamous Apollo 13 mission when engineers used at least 15 computer-controlled models to assess and recreate conditions on board the crippled spacecraft 200,000 miles away, and using that information to guide the crew home in one of the most epic rescue missions in the American history. If we go to the AEC industry, we are going to see replicas of real-world buildings as digital twins that will enable the bidirectional data connections between the physical and the digital worlds. And what the digital twin normally does is that it utilizes all the data generated in the planning, in the design, and during the building stages of a project. And then it supports the entire build asset through the life cycle, and it supports the operation of the building. So what they basically do, these twins basically do, is they allow the operators to be ready to deliver better occupant comfort, to have structural building asset data to improve the building performance across their entire portfolio. So as you start seeing, the digital twins are starting to become so much more important for the architectural, engineering, and construction industry. So you can build twins in the AEC industry for a building, for an infrastructure element such as a bridge, or for a complex ecosystem of connected assets, such as a railroad network, an office park, or even a whole city. Okay, so from a workflow standpoint, digital twins unlock data that's traditionally been trapped in silos or in paper files. As a result, teams are better connected through the entire lifetime of a project from this design to decommission. Okay, By integrating static data, such as component specifications, maintenance schedules, when you combine that with dynamic data as occupancy rates, environmental conditions, digital twins empower everyone, from designers to owners, to make informed decisions that maximize the performance and life cycle of an asset. With BIM, with Building Information Modeling, um, it is driving the digitalization of the construction industry using multidisciplinary models. The more we advance in this industry nowadays, you will find that not only the architect is starting to build models, but also all the MEP industries and the structural industries. And then with cloud collaboration, you can start joining all those assets together in one location. So digital twins are going to use the full potential, connecting all the data, all the processes with dynamic, real time, bi-directional information management. Digital twins could be created without BIM, but then at that point, bringing them to full potential starts with integrated workflows and information sharing that already are integrated in the workflows of BIM. So when you start with BIM, it is a much more efficient way to get there. Digital twins give multidimensional views into how an asset is designed, how it is performing, including occupant behavior, use space utilization, traffic patterns. So a digital twin offers a means to test what if scenarios, including the impact of design changes, weather disruptions, security events. It collects substantial data from one environment. How does digital twinning work? So a digital twin works by integrating a building system, sensor and utility meter data with intelligent multidimensional digital models. A true digital twin possesses the operational and behavioral awareness necessary to simulate, predict, and inform decisions based on real world conditions. So we are all the time through this digital model observing how the real world counterpart is behaving, and we're going to be able to predict, and we're going to be able to act ahead of time to many times prevent issues with, before they happen, to foresee problems before they happen. So how does digital twins actually use BIM? So in the BIM process, we are incorporated data that was created during the planning and design phases. And then the digital twin extends that data capture into the construction and operational phases of the assets. You can also inform planning and design for future projects. So realizing the full project promise of digital twin requires multidisciplinary models at the core and an integration of systems and data across workflows and between organizations. And for that, we have already discovered a while ago that BIM is the most efficient path to the creation of an accurate, high value digital twin. So just to gather this up in one concept, in design and construction for the architecture and the engineering and construction industry, a digital twin can be multifaceted and extremely cost-effective way to iterate and test new ideas before you even turn soil. And you can change any number of variables, from a facade design to a number of levels, from your wiring diagram, your HVAC needs, even the impact on the local environment can change automatically as the design changes. In later phases, once your project is complete and in use, the digital twin is still an invaluable asset. the way workspaces use light or power, the way people interact with the built environment, and any number of other measures can be taken, digitized and automated, ingested into your digital twin to reveal efficiencies, performance enhancements in the building or an asset in use. I mean, you can pre-program maintenance schedules for your air handling units. You can accurately pinpoint locations where, for example, pipe broke. All those really, all that important data is going to be included within the digital twin. So, how does digital twinning work in construction? So, in the construction industry, you can have operational data for HVAC, mechanical, electrical, plumbing, all the MEP systems. You can have parts and maintenance data. You can have environmental data collected through sensors. So on a new building, a digital twin is created as the outset of a project, as AEC teams and owners work together to define the performance goal and desired outcomes. As the project proceeds, data is continually connected and collected and mapped to the model. And I mean, you can use a platform like Tandem. And then when the asset is handed over to the owner, the digital twin will connect operational data that can be used to fine tune performance and manage maintenance over the long term, as well as support decommission and future use. Because the digital twin is always evolving with the data supplied by its physical twin, it can perform simulation and predictions in response to real time conditions. In the construction industry, a digital twin makes iterating changes faster and much more cost effective during the architecture phase and during the building phase. One example would be to align a building's solar facade to follow the path of the sun or modify indoor airflow to minimize the spread of pathogens. So the types of digital twins, and each type of digital twin will require a greater degree of maturity in digital transformation offering, increased value to your business. So level one is a descriptive twin. The descriptive twin is a visual replica with live editable design and construction data, including 3D models and BIM. The second level is the informative twin. The informative twin uses increased integration for sensors, operations data, for insights at any given time. The predictive twin will capture real-time data, contextual data, and analytics to identify potential issues and to predict, as I said, it's going to let you know when the lifetime of a piece of equipment or when something is eroding and corroding, you will be able to identify those issues ahead of time. The comprehensive twin will leverage advanced modeling and simulation for potential future scenarios, as well as prescriptive analytics and recommendations. And at the last level, we have the autonomous twin, and that one has the ability to learn and make decisions through artificial intelligence while using advanced algorithms for simulation and visualization in 3D. Other ways digital twins can be used to optimize built assets. You can configure retail spaces to take advantage of shopper patterns. You can maintain productivity and occupant comfort in office spaces. You can increase sustainability measures by optimizing energy usage and other building inputs. Automating indoor farm operations for optimal growth conditions. And this is something that is becoming more and more important as we continue to evolve in this modern world. Predicting maintenance problems in oil refineries or in any building. and designing healthcare spaces for efficient patient flow and staffing needs. So all these situations show you how important it is. And the more we modernize our AEC industry, the more I see the need for this digital twins. And then, as an example, uh, Singapore. I mean, and this is an example that digital twins are not limited to a single instance. You can integrate multiple digital twins, and designers can build a connected ecosystem and optimize that system's performance over time. When you think beyond the individual asset and you can start to consider its broader potential in economical, social, and environmental terms, imagine building a smart city that can be managed using real time data, analyzing and optimizing energy consumption, wireless networks, public transportation, security systems, and infrastructure performance in real time throughout geodata modeling and low IT sensors. Smart cities can even adapt to changing climate conditions and run simulations for responses to emergencies such as pandemics and natural disasters. Because digital twins can collect and interpret data about things like population growth, natural resources, and climate condition. They can help build more resilient cities and empower industries to better respond to global challenges. This is already happening in cities around the world. And I think the biggest example of this is Singapore. The future of BIM and digital twins. So if we go back to the beginning of it from 1960 with that spacecraft scenario that NASA built to nowadays, um, the industry has grown, and through BIM, we have a life cycle management of our assets. The potential of digital twin is clear, has been clear. The better computing power that we have nowadays, the connectivity, and the sheer data storage that we have today make it so that nowadays we can implement this technology. Okay, and with this, guys, I want to open up the floor for questions.